Okay, let's see more examples, which are still of calculus type integrals. The calculus 1 type integrals. Uh, by that I mean that you have seen these kinds of integrals in calculus 1. So 40 times cube root of x to the 5 minus AD over cube root of x to the 5 dx. And at the end, I want to write the final answer in this box. Again, try to do this on your own. You have seen these kinds of examples in Calc 1, and that's a good practice as a reminder how you dealt with these kinds of integrals. Okay, I have a difference of two functions. There is a minus here. It's a difference of two functions, so that can split into the difference of two integrals. The integral of 40 cube root of x to the 5 minus integral of 80 over cube roots of x to the 5. Using basic algebra, we know that cube root of x to the 5 is the same as x to the power of 5/3. In the other integral, cube root of x to the 5 is in the denominator. When we move it to the top, it becomes x to the power of negative 5/3. From the first integral, 40 can be pulled out because it's a constant. You know from Calc 1, as I mentioned before, that in an integral, we can pull out a constant. So for the integral x to the power of 5/3, and we know how to deal with integral of x to the power of 5/3 using the power rule. It's gonna be x to the power of 5/3 plus 1, which is 8/3, all over 8/3. Minus AD times and antiderivative of x to the power of minus 5/3 using the power rule. X to the power of minus 5/3 plus 1 is minus 2/3, and all over minus 2/3 plus c. The rest is just a little simplification. Here in the first fraction, 8/3 is in the denominator, so when I bring it up, it becomes 3 over 8. So 40 times 3 over 8 will be that coefficient. And x to the power of 8/3. We have two minus here, so the next term becomes a positive term. And AD times 2/3 is in the denominator. When we move it up, it becomes 3/2. And times x to the power of minus 2/3. We need to avoid negative exponents in our final answer. So I need to move x to minus 2/3 back to the denominator, so I will have a positive exponent. I'll do that in the next step. So 40 times 3 over 8, obviously it is 15. So and 80 times 3 over 2, which is 120. As I mentioned, we avoid negative exponents in our final answer, so x to the power of minus 2/3. Using basic algebra, when it gets moved to the bottom, it becomes x to the power of positive 2/3, and all plus c, because it's an indefinite integral. So the final answer, as we calculated here, was 15 times x to the power of 8/3 plus 120 over x to the power of 2/3 and all plus c. The next example is a definite integral. So we need an exact answer for this. So no calculator to estimate or approximate the value of the integral. Again, please try this on your own before watching the rest of the video to make sure that you will get the correct answer. And just let me emphasize here, I want an exact value here. Of course, if applicable, we need to simplify as much as possible, but we don't approximate using decimals. So first of all, I can pull out 8 because 8 is a constant. So this becomes 8 times the integral of 1 over z dz. And the integral is over the interval from 1 to 5. As you remember from the reminder that we had before, and you have seen in Calc 1, antiderivative of 1 over z is ln of absolute value of z. We don't need absolute value here. We just need ln of z. Why? Because we are integrating from 1 to 5. From 1 to 5, there is no negative value, so we don't need absolute value. All the numbers from 1 to 5 are positive. So this should be evaluated at the end point or limit points of the integral. So the value is going to be what? This function evaluated at 5, which is going to be 8 ln of 5 minus this function evaluated at 1, 8 ln of 1. Is there any way we can simplify this? Yes, you know that ln of 1 is what? Is 0. ln of 1 is 0, so this is just 0. I can't do anything about ln of 5 as an exact number. So the final answer is just 8 times ln of 5. Let me also do an example with the exponential function. Just as a quick reminder, again from Calc 1, you know that the derivative of e to the x is e to the x. In terms of the integrals, it means that the integral of e to the x is e to the x plus c. Just as a reminder from Calc 1. So let's do a definite integral using the integral of exponential functions. the integral from -1 to 0, 3 times e to the power of x dx. And I want an exact number. For example, if you have e in your answer, you should keep the e, unless it is e to the power of 0, and e to the power of 0 is 1, but e to some number remains there. And also avoid negative exponents. So if you had e to some negative number, move it to the bottom, so you will avoid negative exponent in your final answer. Again, try to do this on your own before watching my solution. First of all, 3 is a constant, comes out. Antiderivative of e to the x is e to the x. So 3e to the x, and we should evaluate this function, this antiderivative, at the upper and lower limits of the integral and do the subtraction. This means that this function evaluated at 0, which is 3e to the power of 0, minus this function at -1, 3e to the power of -1. E to the power of 0 is 1. So the first term is just 3. The second term, to avoid negative exponent, if I move e to the -1 to the bottom, this becomes 3 over e. And that's the answer that we need to type in here, 3 minus 3 over e. As an exact value for this integral, we cannot go further. The other thing that I need to remind you from Calc 1 is the substitution methods. Part of substitution method is discussed in Calc 1, but of course in Calc 2 we'll see more of the substitution method for different kinds of functions. But first, let me in fact, still we are reviewing from Calc 1, so the type of substitution that you will see are not anything new. They are similar to Calc 1 kind of integrals that we use substitution. So for example, suppose I want to do the integral of 2x times x squared plus 3 to the power of 100 dx. On purpose, I used a large exponent to see that how, I'm sorry, it was x squared plus 3. Please make this correction. I wanted to show that how important the substitution is to solve this problem like this, because it's not practical to expand x squared plus 3 to the power of 100. But doing the substitution makes it much more simple. As you might remember, in the integrals that we use substitution, we introduced a new variable, the letter that is very common, as you have seen in Calc 1, is the letter u. So let u be, in this example, let u be x squared plus 3. The derivative of u with respect to x is 2x, right? The derivative of x squared is 2x. The derivative of 3 constant is 0. What does that mean? If you do the cross multiplication algebraically, it means that du times 1 or du equals 2x dx. So this substitution makes the integral much more simple because I let this be the new variable u, and the 2x dx is the same as du. So now 2x dx is du. So what I'm gonna have is this becomes u to the power of 100 du. Now we can deal with this using the power rule, right? U to the power of 100, the antiderivative is u to the power of 101 all over 101, and then plus c. As you know, as you have seen in Calc 1, in the problems, in the indefinite integral problems that we do, we use the substitution. We need to go back to the original variable. We need a back substitution. What does that mean? It means that the original problem was in terms of x. It was integral of 2x times x squared plus 3 to the power of 100. The variable was x. I need to go back to x. How? Just make this simple substitution. U is x squared plus 3. So instead of u here, I just use x squared plus 3 to the power of 101 all over 101 plus c. And that's the final answer. So this was the way that we did this indefinite integral uh, when the substitution was needed. Let's try another example. Please try this on your own. I know that you have done this kind of examples in Calc 1, but still, as a reminder, that will be very helpful that you try this on your own. So x squared times x cubed plus 5 to the power of 6 dx. Using an appropriate substitution, try to do this integral. So inside this rectangle, let me write down what substitution we are going to use. If you use this substitution, this is the correct one to work with. U is x cubed plus 5. Now the derivative of u with respect to x is what? The derivative of x cubed is 3x squared, right? If I do the cross multiplication here, I can think of 3x squared as 3x squared over 1. So du times 1, which is du equals 3x squared times dx. There is a it looks like there is a problem. The 3 that we see here is not in the integral. We didn't have that problem in the previous example. Like when I had du is 2x dx, 2 was there. As you know, this is not a big deal. We can resolve that. If I divide both sides of this equation by 3, now x squared dx is du over 3, meaning that x squared times dx is the same as du over 3. So this can easily be resolved. And u was, in fact, whatever I had inside these parentheses. So this is going to be the integral of u to the 6 du over 3. That over 3 is like 1/3 has been multiplied by du, and 1/3 is a constant, can be pulled out of the integral. So this is going to be 1/3 integral of u to the 6 du. Antiderivative of u to the 6 using the power rule is u to the 7 over 7, and then plus c. So this is u to the 7 over 21 plus c. Are we done, or we need just one more step? We need one more step, and that's the back substitution, which means that you replace u by x cubed plus 5. So it's going to be x cubed plus 5 to the power of 7 all over 21 plus c. And that's the final answer. So x cubed plus 5 to the power of 7 all over 21 plus c. Since it's an indefinite integral, we need to have plus c at the end of our solution.